In 2.5, we're going to look more at variation. Make sure you look at the video where we have examples from the textbook. These are looking a little bit more at some applications. And that gives you the introduction more to just the structure of direct and inverse variation. So if we look at number 1 pencil problem, we've got the height that a ball bounces varies directly as the height from which it was dropped. Now everything that we've done so far is usually y varies directly with x. So we have here that y is the height that it bounces, and x is the height from which the ball is dropped. Okay. Since it's direct, we will be using y equals k times x. So a tennis ball is dropped from 12 inches. So the height that it's dropped is x. And it bounces 8.4 inches, which is what we said y was. Let's divide both sides by 12. 8.4 divided by 12 is 0.7. Now let's plug that back into our equation. So we have y equals 0.7 times x. From what height was the tennis ball dropped if it bounces 56 inches? So y is what the height of the bounce is. So that's where my 56 will be. 0.7 times, we don't know how high it was dropped from. Divide both sides by 0.7. And we'll get 80 is equal to x. Now your units were all in inches, so this is 80 inches. Okay. Number 2, and leave yourself some space here. On number 2, radiation machines used to treat tumors produce an intensity of radiation that varies inversely as the square of the distance. I'm going to highlight that, or I'm going to forget that it was square of the distance from the machine. Okay, so we have y varies inversely with x squared, where y is the radiation intensity and x is the distance from the machine. Okay, now inversely we know we would set it up as y equals k over x squared. Now let's plug in the information given at 3 meters, so that's the distance. The radiation intensity is 62.5. Now let's do a little bit of arithmetic. So 3 squared is 9. To get k by itself, I'd want to multiply both sides by 9. 9 times 62.5 is 562.5. That'll give me k. So let's plug that back into our equation. We'll have y equals 562.5 over x squared. And then the question asked of us was, what is the intensity at a distance of 2.5 meters? Remember, distance is the x. So what is the intensity? 562.5 over 2.5 squared, which is going to be 562.5 over 6.25, which will reduce to 90. Now if I look at my units here, the units are in, notice it says radiation intensity is 62.5 I'm not going to even try it per hour, but we know that that would be, we'll put here milli per hour and feel pretty good about that. Okay. And then lastly, number 3, BMI takes both weight and height into account when assessing whether an individual is underweight or overweight. BMI varies directly as one's weight in pounds and inversely as the square of one's height in inches. Let's go ahead and get that part down, and then we'll come back and read the rest. But I've got the BMI, so we have Y, where Y is going to be the BMI, varies directly with one's weight in pounds, so we'll let that be X, and inversely as the square of one's height. So the Z will be the height. And if you want to use variables like a B and a W and an H, that's fine too. Okay. Now, in adults, normal BMI are between 20 and 25. Inclusive means that that would include the 20 and the 25. Values below 20 indicate they're underweight. Above 30 means that individual is obese. A person who weighs 180 pounds, that would be our X, and is 5 feet or 60 inches. Remember that we do need to reference it in inches, since it says one's height in inches in the problem. So it's 60 inches, has a BMI of 35.15. Okay, so let's find K, and then we'll come back to the rest of the problem. 35.15 equals 180 K over 60. Let's break that down just a little bit. And it's actually over 60 squared. Sorry about that. We didn't plug in but put the squared there. So it's over 60 squared, and that 60 squared is 3,600. I'm going to multiply both sides of the equation by 3,600. So 3,600 times 35.15 is 126,540. That equals 180 times K. Divide both sides by 180. And we will get 703 for our K. And once we found our constant of variation, let's come back up and start over. Y equals, the K is 703 times X over Z squared. And then our question is, what is the BMI for a 170 pound person who's 5 feet 10 inches tall? So the BMI is Y, we're trying to find it, equals 703 times X, which is the weight, 170 pounds, over, now 5 feet 10 inches tall. Remember that we have 5 feet is 60 inches, plus another 10 is 70 inches in height. So we'd have 70 squared. So 703 times 170 should give you 119,510 over the 70 squared, which is 4,900. That would be 24.389, and we'll round to the nearest tenth, like they mentioned, 24.4. So if you're asked, is that person overweight? And the answer would be no, because normal values fall between 20 and 25. So we would say not overweight.